Good afternoon, everyone. Welcome to the monthly computational social science webinar at the Chinese University of Hong Kong. I'm Jamin Lee. I'm an assistant professor of sociology at CUHK. Today, it is my great pleasure to introduce today's speaker, Professor Arnout van der Rijt from the European University Institute. Professor van der Rijt is a leading sociologist whose work spans social networks, collective action, and computational social science. He received his PhD in sociology from Cornell University in 2007 and has held faculty positions at Stony Brook University and Utrecht University. And Dr. van der Rijt is currently editor-in-chief of sociological science and president of the International Network of Analytical Sociology. His contributions have been recognized with prestigious awards, including the Linton Freeman and Raymond Boudon Prize, which is one of the highest honors given to social network scholars. And personally, I'm really excited because he has pioneered things that I really like, formal models and field experiments on the Matthew effects, and also done rigorous research on media bias and inequality. And today's talk sounds like an exciting extension alongside that line of research. So I have no doubt many of us will like it and learn both theoretically and methodologically from his research. So I gotta stop talking. Please just join me welcoming Professor van der Rijt. Floor is yours.
Thank you very much. It's a pleasure to share my work with you today. Thank you for this kind invitation. I hope to live up to this very high level that you set for in expectations for my talk. So I will do my best today. And let me start off by saying that the work that I'll be presenting is based on a collaboration that I was lucky enough to have with Martin Arvidsson of Linköping University, who's really done most of the work here, as well as Mark Koischnik from the University of Leipzig. And yeah, the question that we are asking is this: do unlucky events or lucky events have snowball effects on life success? So what do we mean by that? To give you a better idea what we mean by that, we give the example of an anecdote that was mentioned in Desmond 2016 that describes a series of events that begins with a young boy hitting a passing car with a snowball. The driver of the car chases the boy back to his home, breaks the door in, threatens the family, and leaves. The damage done to the door, however, provides a justification for the landlord to evict the family. The family subsequently struggles to find adequate housing, moving from one insecure situation to another, until social services eventually breaks the family apart. So it's a very sad story, but it involves in two ways a snowball. Of course, the snowball is the triggering event that leads to a series of negative events. And this series of negative events we might call a snowball effect. And the question this raises, of course, for sociologists, including myself, is without the snowball incident, how much better would the family have fared? And I would say, and my colleagues would say, that there's a lot of events in the life course like this that are lucky or unlucky, and that may have snowball effects that cascade throughout the life course. So these are lucky events such as unlucky events such as falling just below the admissions thresholds for an elite college, whereas the lucky version of it would be to fall just above that admissions threshold. Your parents divorcing over an affair, depending on the context, this may, if it is a very unhappy marriage, be a lucky event. Partner getting cancer, an unlucky event. Entering the job market in an economic boom would be lucky. If it's a recession, it would be unlucky. Growing up with an older sibling, your classmates are all younger than you. You're promoted early because of a retiring senior colleague. That is a serendipitous opportunity. Or you're laid off due to a firm closure, whereas some peer elsewhere is not being laid off in a similar firm. And in each of these cases, we may ask the same question that we originally started with about the snowball. Is each of these events going to lead to a sequence of other events that would basically pull you apart from the trajectory that you would otherwise have had, that your alter ego who didn't experience the triggering event would have. And yeah, we have theory about that. And I think like there is it's not just a theory, it's kind of a meme, an idea that persists throughout sociological literature and also beyond, that suggests that, you know, advantages and disadvantages accumulate. So it is not just the case that one, there's a direct effect of the unlucky event on someone's life, whether this be their education, their income, their happiness, their health, right? Because that initial event introduces an inequality in life success. But it is also the case that once that event has happened, this is going to be reinforced, perpetuated, and that inequality that's initially created by this event is going to grow and create an increasing rift between the lucky and the unlucky. And that idea is sometimes, colloquially referred to as rich get richer effects or success breeds success effects, or the Matthew effect as introduced by Robert Merton in 1968. And then here it has the 1988 reference that revisits this concept: initial comparative advantages that make for successive increments of advantage, such that the gaps between the haves and the have-nots widen. And in their well-known review of the cumulative advantage literature, Tom DePreet and Gregory Irish define cumulative advantage as a favorable relative position that becomes a resource that produces further relative gains. So this idea of an advantage being given to someone serendipitously or a disadvantage to the alter ego, and that producing an increasing gap, that is a central idea in the sociological literature, we would say. And having set the stage like this, what you might expect is that we're going to push against that idea, and that's indeed what we will do today. Because in the context of the life course, there are many events. And this poses an issue conceptually to the idea of the Matthew effect in the life course. So even though there's a huge literature out there that identifies persistent inequalities and bad things happening to people to whom something bad happened before, just as in the example of the family and the snowball, it is the case that the life course is full of chance events. Right? We had the list of the events that we already mentioned, but they all have to fit in that same life course. So the same people who are either the oldest sibling or the youngest sibling or somewhere in between, they also may or may not experience a parental divorce. They may also get lucky or unlucky at the university, getting in or not into a famous university that will later allow them to become more famous or have a higher earning job. They are subject to chance when it comes to health complications of their family members, the labor market entry conditions. And unless each of these events is strongly correlated with the other events, it's very difficult to see how you can have a domino effect across them, right? Because reinforcement suggests that past luck will be positively correlated with future luck. That's exactly how luck perpetuates itself across a series of events. But this is not intuitively true for the events that we see here, because it's not very clear that being the firstborn is going to be a strong predictor of being the oldest in class. And it's not clear that a parental divorce early in life is going to be a strong predictor of whether or not you graduate during a recession. These seem to be completely orthogonal events. And a firm closure experienced in my 30s, is that going to predict whether my partner is going to have health problems in my 40s? Probably not so much. And so we think about this collection of chance events and all the other events that are not even listed here that you might come up with. They do not appear to be strings of dominoes, where it's a series of positive events or a series of negative events, but rather probably a mixture. So what we argue is, if the life course is a sequence of mostly orthogonal events, or even if some events are orthogonal, that is good enough for us, right? Some things might cascade, but then there's some other event that is just orthogonal, lightning, bad weather, and that prevents something from happening that would otherwise have been good to you. Then it must be the case that good luck in one setting will ultimately be countervailed by bad luck at another point. The lotteries can cancel each other out. So you might have a supportive teacher in high school, but then your parents got divorced. Or you might have grown up as the oldest sibling, giving you an advantage because that means in the first few years of your life, you had all the parental investment and attention, and that you're the second born never had because they always had to share with you. But that advantage is then counteracted by the fact that you graduated in a recession. So the cumulative effects of chance might then wane with time and fizzle out. So these are now conceptual ideas. And what we're going to do is, because we're at a very high level, the entire life course, is try to model this with a very basic kind of general model and see if we can recreate these intuitions that we had before in this modeling context. So let's first try to create the idea of a Matthew effect in this modeling context. So we start with the Polya-Ern model, which is a very basic model that is the basis of many reinforcement models in the literature. And we can think, if we think of the life course as a sequence of lotteries, right, then the analogy of that would be that we have an urn that is your life, and we are drawing balls from that urn, and they're either black or red. When it's black, something good happens. When it's red, something bad happens. And there's reinforcement because each iteration, every time that we draw a ball from this urn, we put that ball back in the urn after drawing it, but we add a copy of that ball. So if in the first round you have bad luck because we draw a red ball, now we put a red ball back and a copy of the red ball. So now the chances on the second draw of an unlucky bad event happening has gone up because now there's 2 red balls and only 1 black ball. So clearly in this simple model, the lotteries are going to be strongly positively correlated with each other. And it should be able to reproduce the cumulative disadvantage dynamic or the cumulative advantage dynamic if we start with a black ball, or if we initially have a large number of black balls. Yeah. Right, but now what we've done before in the talk is conceptually problematize this by saying, well, I can come up with a lot of life events that have nothing to do with everything else that came before. So to model that, we're now going to introduce a second urn, right? So the initial urn we're going to call P on the left, and the second urn that we introduce is now this urn E. So we're going to occasionally allow an uncorrelated lottery. So how do we do that? Well, again, we're drawing balls from urn P. That's what we did before. And P again starts with a red ball and a black ball. And again, if with probability Q, we do the same thing as before. So we draw a random ball from urn P, look at it, see that it's red. So we put it back and another red ball in urn P. But now, with some probability, 1 minus Q, we draw a random ball instead from urn E. And we put it back in urn E. And then we add a copy of that to urn P. Right? So now you see that what we add to urn P is independent of what has previously happened to you based on the previous draws in urn P. Yeah. Now, and you can see that if we make Q equal to 1, right, then we never draw from urn E, and we're back to the original Polya-Ern model. Yeah, and these models are part of the general definition of generalized Ern processes as defined in Hill et al. 1980. So we know what sort of behavior these processes exhibit. So that's what we'll get to now. But just before we do that, to reiterate, what we've created here is like a generalization of the Polya-Ern process with an extra urn that allows us to introduce the idea of independent events. These are just chunks that have nothing to do with the prior history, and they should have this countervailing influence. That's what we had theorized, but now we're trying to back that up with this modeling framework. So here's how we do that then. So we iterate, we simulate through these processes, and we also analyze them theoretically on the basis of the generalized Ern processes as defined in Hill et al. 1980. So this Polya-Ern model we know converges almost surely to a uniform distribution on the unit interval 0 to 1, meaning that any degree of luck running from 0 to 1 is equally likely ex ante. So it's possible that you happen to draw a couple of red balls. Yeah. Then the ultimate fraction of red balls is probably going to be very high. So you'd end up, yeah, here in the, I don't know if you can see my cursor, but you'll end up high up in the figure. And you can see when Q is 1, that's the original Polya-Earn model, the lines are flat. It means they converge. And you can see that they kind of cover the entire space from top to bottom equally, and that's that uniform distribution between 0 and 1 that we also derive theoretically. So here, there is this lock-in. There are Matthew effects, and early chance, it has a persistent effect throughout the life course. Yeah, so right, the x-axis being the number of draws, and it's on a logarithmic scale. So at the end of the chart, we have 10 to the 5th draws. At this point, everything has stabilized. If we think of this as the end of the life course, right, you've equilibrated, you've locked into a certain fraction of red balls that is stable over time and is being reproduced from one period to the next. Now, the modified Earn model, which is the middle and the right chart that you're looking at, here again, the x-axis is the number of draws, and the y-axis is the fraction of red balls. But what now happens is this convergence that we had predicted. So with time, there are these countervailing influences from drawing from the second Earn. And because of that, the advantages are not maintained and the disadvantages also are counteracted over time, so that there's a tendency for your life to kind of return back to where it was meant to be. So there's a sense of fate, if you will. So in this simplified model, there are disturbances and they might give your life a jolt in a positive or negative direction, but there will be a tendency with time for this initial advantage or disadvantage to disappear or become smaller towards that average of 0.5 that you see that. And also theoretically, we analytically analyze this model, we can show that it converges almost surely to 1/2 as long as Q is smaller than 1. Yeah. So now we have this conceptual idea of no locking, of self-correction, countervalence. Uncorrelated events cancel each other out, and that leads the initial advantage or disadvantage to be lost. New advantages might emerge, new disadvantages might emerge, but also they are eventually counteracted with time. And so there's a tendency. Now the life course is kind of this bumpy course that kind of moves around a trajectory that is kind of set. That is the idea here. So if everybody's fate is the orange line, then there will be a tendency for people to drift around that fate, sometimes being pushed to the left or to the right, but ultimately converging back to that stable life course. Okay, so that then leads to, based on this formalization also, 2 hypotheses about the role of chance in the life course. One is that an unlucky event on the effect of an unlucky event on success grows or is sustained at least with time. And the other, that is the classic Matthew effect. And the other is that there's this sense of countervalence that, there's only a temporary and fading influence that an unlucky event has on success in the life course. These are 2 contrasting hypotheses, and they set the stage for the empirical analysis that we're going to do now. So what we would like to see is which of these 2 alternative versions of the life course are actually the ones that we live. Of course, we don't know. We only live one life. So we have to do something else in order to figure out what the long-term effects of chance on success in life are. And what we will do is go to Swedish register data. So the Swedish government collects on all Swedes detailed life histories. And because they've been doing that since the middle of the 20th century, even longer in some respects, but we have these long stretches of millions of life courses that we can look at, and there we can find Swedes who are similar up to a point, and then something happens in the life of one Swede, but not the other, and then we can see if whatever unlucky event distinguishes the one Swede from the other, durably sets them apart in terms of life success, or whether these Swedes will eventually have the same level of success again. when we go far enough into the future, which is what we can now do with this historical data that goes far back into the in time. And we will analyze this using causal designs from event-specific literature. So we're going to exploit some kind of random element in these events. They are lucky events after all. And we will use that to be able to say, basically what happened here is two Swedes, a coin was flipped, one got lucky, the other got unlucky. So now we can causally identify the effect of that event. And we will use a single outcome variable, wage, and specifically wage ranks as a success measure. It's a continuous measure. It's long observed over a long, you have wages starting from when you enter the labor market all the way to retirement. So it is something that we can persistently track using a single metric over time. And of course, it's also a central outcome variable in terms of life success that is often analyzed by sociologists and economists. And that what we will do is also look at US survey data. Now, there we don't have millions of lives, but tens of thousands, and see if the patterns that we find in the Swedish data can be replicated. The US is interesting to compare with Sweden because there have been comparisons have been made in the past, and of course, intuitively, also the US is a country where maybe if things go wrong, there's less of a social safety net to help you get back on track. And so arguably, it's a tougher case for the second hypothesis of self-correction, to be tested. So here, I'm going to go through the 6 events now so that you see what we're doing here. Now, bear with me. This is a little bit of work, both in terms of mechanisms and methods. And I will go through this faster than you would normally have in a talk where you would only discuss one causal inference strategy. Also, because we're borrowing these from the literature, it's not like we have to spend too much time going over each one of them. But I will nonetheless mention each of the 6 events that we analyze. So we start early in life, the birth lottery, and say, well, whether you're born in December or January in Sweden, that matters a lot because it decides whether or not you will be the oldest or the youngest in class. And this is known to have at least an educational advantage through some portion of one's life course. And the mechanisms here are the developmental disadvantage in class. So if you are the youngest in class, you look like the least intelligent, the weakest, the one with the seemingly strongest learning disability. If you are born in January and you are the oldest in class, it looks like you're stronger, faster, smarter than everybody else. And this might even be reinforced by teachers who are unaware of these age differences, which are significant early in life. Of course, if you're 4 or 5-year-olds, it's going to be up to 20% of your life course. Some have lived 20% longer lives. And if the teachers reinforce that, they might give more opportunities and attention to the kids that are, or group them put them into multiple tracks, where the ones that are born earlier, like in January, are given a greater opportunity to move faster forward. And we basically exploit the natural discontinuity around January 1st, where we follow the literature and assuming that it is difficult to time the birth before or after that cutoff date. So this is an as-if random event, and that we will follow, and then we will see if January and December children have different life courses. The second event is being born second or first, so whether you are the oldest or the second born sibling. And here the mechanisms are the one that I mentioned before early in the talk, resource dilution, right? The firstborn child has more resources available to them because they don't have to share it with their siblings for at least the first few years of their life until the second is born. And there might also be, depending on cultural context, there might be parental expectations for the firstborn that are different from the secondborn. There may be sibling dynamics where the firstborn is stronger and get to dominate the secondborn, and this may also have effects, as has been theorized in the literature. And the method we will be using here, sibling fixed effects. So we're holding the family environment and the genetics of the parents fixed, and we're exploiting the ordering of the parent or of the siblings as a inference strategy. Assuming that your coin was flipped, who was born first, which is a conservative strategy because, of course, there may be slight biological differences also between the first and second born, although their effects have been found trivial in prior work. Low SCS peers. So here the mechanism is that, well, if my classmates are children from parents who set high educational goals for them versus low SCS peers where the children might have, the parents might have very different expectations for the children, that is going to improve or deteriorate my educational environment when I'm young. Through the negative spillovers, there isn't the kind of reinforcement in the classroom of high achievement in low SCS groups versus high SCS groups, perhaps a lack of competition and lack of cultural exposure through the children of other high educated parents. And so that environment might have an impact on one's educational performance and then ultimately impact one's income much later in life, if this all snowballs. The method here is sibling and school fixed effects. So what we're able to do here is look within families and then also look at if you as one of the siblings happen to go to a particular classroom in the same school as your sibling, in which there happen to be more high SES or classmates versus your sibling. So it's a very tightly controlled setup. Fourth event is falling short of an elite university admission threshold. So we fast forward in life. Now we are, at the university admission state. And the nice thing about the Swedish data is that they have data on all the test scores that on the basis of which admissions decisions are made. So we can use a fuzzy regression discontinuity design. Fuzzy because some people who make it in ultimately decide not to follow through with that university, and others, therefore, who had fallen just below the threshold, they might still get a chance. That is why there's some noise around the threshold. But nonetheless, we are using the initial placement as instrument. We can look at the effect of being lucky to be admitted to an elite university. And here, the idea is that an elite university, for example, the Stockholm School of Economics, will on the Swedish labor market give you a leg up because this is a credential that employers might derive greater skills or greater ability from. And this might therefore impact your starting wage. Okay, then a negative event, firm closure. Now we're again a little further. You are working you're participating in the labor market, but now there's a firm closure, which means that there's an immediate need to accept lower paying job, or you may be temporarily unemployed. And there might be a loss of human capital, and also the reputation effect of having been unemployed might send a negative signal to future employers, and there might also be psychological factors of having failed. And these effects together might lead firm closure to have a negative impact on wages in the long run. Sure, of course, they will have these effects in short run. The question is whether they persist in the long run, or whether they get self-corrected according to hypothesis 2. So here, this is perhaps the weakest inference strategy because we use coarsened exact matching on pre-treatment wage trajectories, and then verifying that pre-treatment the wage trajectories of matched individuals are the same. And then finally, we look at graduating in a recession versus in an economic boom. And so here the mechanism is that obviously it would be harder to find a well-paying job in such a situation, the higher chance of unemployment, which is not a great thing at the beginning of your career. And there's the potential of long-term unemployment scarring due to loss of human capital for the same mechanisms that we saw under firm closure. And here the method is to instrument field-specific employment conditions at graduation with predicted changes based on entry year and nominal study duration. So what this means is, because there's the threat that people might stay a little longer in school in order not to graduate in a recession, what we need to do is take that selection effect out, and we do that by looking at the employment conditions they would have seen had they graduated at normal time. This is also a strategy that has been used before in the Vandenberg 2018 article on labor economics. Okay, so in the Q&A, I'm happy to talk about the inference details of any of these models. And by happy, I mean, I hope that I remember all the details. There's a lot here. Yeah, now without further ado, I'd like to go to the results, because otherwise we cannot finish the talk on time. And also we don't want to get mired in all the technical details here. So the first check before we're going to look at the wage dynamics is to say, okay, we have these 6 events now. If there are domino effects, right? The whole point of problematizing this was to say, in order for these dominoes to take place, these events have to be strongly correlated with each other, positively, specifically, right? Because one good event needs to lead to another good event. And what we see here already is that kind of sanity check, that there can be a strong Matthew effect across these events, across the life course. That sanity check fails. So this is not very promising for hypothesis 1, I would think, because clearly it seems to be the case that the Swedish population is split, on these events. There are just as many people who are second born, who are in a high or low SES cohorts, who get rejected or accepted to a university, who are born in December or January, who graduate in a recession. All these events have very little to do with each other. So that means that getting lucky in one of these cases is easily counteracted by getting unlucky in one of the others. Yeah. But of course, these are only 6 events and there are thousands in the life course. So this doesn't prove anything. It just says, well, these are the 6 we happen to look at. So if the dynamics are based on these 6 draws, then we cannot really get a self-reinforcing process off the ground. But it's possible, of course, that many events in between do deliver this. And that's why it's important to look at the wage dynamics, starting from each of these events. So we're going to treat each of these events as the triggering event that produces initial inequality that we can then follow and see if people converge with time with their alter ego, or whether they grow further and further apart over the life course, right? That's what we're going to do now. So we're going to start with the event being born in December, where we had that regression discontinuity design comparing January and December borns. And here what you're looking at is on the x-axis, the age. So how far in the life course are we? And on the y-axis, the wage rank. So a value of there at the top of 0.010, that means that that's a 1%, a 1 percentile increase in wage of the December born versus the January born. Of course, what we see instead is that there's a minus 0.013 percentile deficit of the December born versus the January born, which is consistent with right in the age group 25 to 29 initially. And that is consistent with the literature because it says that the January borns are advantaged in education. And so to the extent that education translates into wage advantage, you would expect that early on in life, early in the labor market, you would see a wage deficit of the December borns versus the January borns. But of course, the pattern that we're seeing here is that as people age, this disadvantage becomes smaller and smaller. And we even see a reversal later in life. I'm happy to talk about where this comes from. But we could speculate where this reversal comes from. This was not predicted. What we had predicted is that this entire dynamic would, over the course of life, converge to 0, which is what we see up to the early 50s, but then we get this reversal. Now, this pattern of convergence, however, is seen everywhere else. So if we look at being second born versus first born, we see that there is this wage disadvantage early on, a little over minus 0.02. So that is a 2 percentile wage difference with being born first. But with time, this wage disadvantage shrinks and becomes insignificant, at least later in life. But several decades go by before this difference disappears, of course. But nonetheless, we see a self-correcting tendency. Then if we look at low SES peers, here we don't see a difference initially, but that's arguably because the kids with high SES peers, they stay longer in school. So when they are 25 to 29, this is a relatively modern cohort for which we have this data. You know, the low SES peers are already those with low SES peers early in life were already working, whereas the ones with high SES peers are maybe still in college or just started their first job. So we don't see a wage difference there yet. But then in their early 30s, we see that the low SES peers have fallen behind, but this effect disappears with age again, just as in the other examples. Not getting into an elite university, for example, the Stockholm School of Economics, that gives you a wage disadvantage 6 to 8 years after, you know, the admission stage. So this is like a few years after graduation. We started with 6 to make sure everybody's graduated, more or less. But this disadvantage, and this is a big one, right? This is minus 0.08. So that is an 8 percentile wage disadvantage of not having that, hey, I went to the Stockholm School of Economics line on your CV. But then with time, you see that this disadvantage disappears, or at least is no longer statistically significant. And also in magnitude is much closer to zero and eventually becomes zero 18 to 20 years after being admitted or not being admitted to Stockholm School of Economics. And then we, on the middle chart in the bottom, we see losing a job due to firm closure. So this is obviously very bad for your wages to lose your job, minus 0.02 percentile points. So you have to accept a lower paying job on average, or maybe you're even jobless for a moment. But this difference with those who keep their job, the control group, quickly, or not quickly, but relatively steadily converges back to zero. And 13 to 15 years, that's of course 1.5 decades later, there's no detectable difference anymore between you and your alter ego who didn't lose the job in terms of wages. Now, you've lost a lot of income in the meantime, but you're now again working at the same wage level, statistically speaking, on average. And finally, graduating in a recession, we also see the same thing happening. Graduating recession is bad for wages. Minus 0.1 is a big effect. All right, 10 percentile points. But as time goes by, this difference becomes smaller. And 8 to 10 years after graduation, we no longer see that those who graduated in a recession are earning different wages from those who graduated in an economic boom. So in each of these 6 cases, there is a fading of the disadvantage over time and a correcting of the course that people were thrown off of by the initial event back to where they were meant to be or would otherwise have been if that event hadn't happened. Now, you could say, okay, but what if there are multiple events, multiple good or bad things happen in life? Do we see the same self-correcting dynamics happen? And here is the answer. So here of course, this is more difficult to do even with millions of lives in the Swedish data because, you know, every causal inference strategy, you know, sacrifices a lot of data in order to get the plausible causal inference strategy. But 2 events we can do, and here we are comparing December and January borns, also in terms of whether they experienced a firm closure or not, which is a rare event. And what you see is that, of course, every time someone experiences a firm closure, that has a negative effect. And also the December borns start off worse than the January borns. But with time, in all 4 combinations, we see it converges back to zero. So if you the dashed red line is people who are double unlucky. They were born in the wrong month, December, and then they also experienced a firm closure. And nonetheless, we see that after age 30 to 34, their wage difference with those who were 2 times lucky, they were born in the right month and they never experienced a firm closure, is the difference has become insignificant. And so, yeah, if even being lucky twice or being unlucky twice doesn't make, you know, does make a difference, but it has a shrinking There's a shrinking difference, and these life courses also with time eventually converge. And if you remember the model pictures, then yeah, you can recognize that it has the same dynamic. The divergence in the beginning, and then with time, a convergence. I think we see kind of a similarity between these patterns here. So showing that this was a very simple model of drawing balls and had nothing to do with the detailed features of the life course, but nonetheless the dynamics do look analogous. Then one might say, okay, that's Sweden. Sweden is a nice country where where you can fail and be unlucky, and then there's a lot of help for you. But let's move to a country where life is a little rougher. United States. Here our data is not as strong, but nonetheless we can use long observed panel data sets to see if we can causally isolate with sufficient power the effects of two chance events. In this case, recession at graduation we analyzed, as well as firm closure in the CPS data and the PSID data. So we have tens of thousands of cases now. I won't go over the causal inference strategy other than that firm closure is based on individual fixed effects regression. So we look over time. We compare wages at different points since the events and also before the event. And then at recession at graduation, we do through instrumental variable regression, again, adjusting for the fact that some people might time their graduation based on economic circumstances. So now we have a linear model because of the lack of power, but nonetheless, we see self-correction if we impose a linear constraint on the data. And we see, that after 10 years, there's no longer a difference between those who graduated in a recession in the United States and those who graduated in an economic boom in the control group. So also here, in this rougher context, we see no evidence for a Matthew effect in the life course, but rather that this negative event, which was significant, more than 3 percentile points in the beginning, eventually wanes, fizzles out, fades. And the same is true for firm closure. Now, here we see maybe a slightly rougher pattern still than in Sweden. It is true that that after 13 to 15 years, after having lost your job, you're not completely back to normal again. In fact, you're still 10 percentile points below where you would otherwise have been. So life has been pretty bad for a pretty long time. Perhaps confirming to some extent that the US is a more problematic context for losing a job. But nonetheless, we see this tendency for things to get better with time, as bad as it is, nonetheless get better with time compared to your alter ego who did not lose a job through firm closure at year 0. So yeah, these patterns are replicated in the United States. So in the life course, we are not finding evidence for a Matthew effect. Rather, we see that every time, in our data at least, that we're able to investigate whenever something bad or good happens, and we compare you with your alter ego, after some time, you start to become similar again, and you seem to go back on course, even if this can, in some cases, take quite a while. Eventually, your career is steered, at least in terms of wage, back to where it would otherwise have been. So you might ask then, well, wait a second, you have a paper on the Matthew effect in science funding, and there you show something very different. So what's going on here, right? Because in that paper, which you see here, the main results shown on the right, you said, well, look, if I compare scientists that got lucky, the green ones, with scientists who got unlucky, the red ones, and I follow them over time, then their difference in luck is going to grow. And it seems that there's a lot of evidence that indeed the luck piles up among the greens and the bad luck piles up among the reds, right? Because the initial event here was whether you land just below or just above the funding threshold. So you have both written about the same quality proposal, and maybe someone in the jury just happened to disfavor the ones and favor the other, or there was some random element over a tiny quality difference that distinguished these two proposals. And that tiny difference with time becomes a big difference in terms of the accumulated funding, which is more than twice as much in the green group versus the red group. So how can we find that and then all this counter evidence in the data that you've shown us today? You might ask, and well, I have an answer to that, and that is the scientific career is a different realm than the life course. So the wage dynamics of the life course, they are probably driven by self-correction, as evidenced by all the analysis that we've shown you. But science is a place of extreme reinforcement where success breeds success dynamics are very strong. And this is something that was known to, for the sociologists in the room, Max Weber already, many years ago, and who said, "I know of hardly any career on earth where chance plays such a role. I may say so all the more since I personally owe it to some mere accidents that during my very early years, I was appointed to a full professorship in a discipline in which men of my generation undoubtedly had achieved more than I had. And indeed, I fancy on the basis of my experience that I have a sharp eye for the undeserved fate of the many whom accident has cast in the opposite direction, and who within this selective apparatus, in spite of all their ability, do not attain the positions that are due to them." So fancy words for saying, I, Max Weber, wasn't meant to be necessarily the Max Weber. This was a fortuitous event. It was serendipitous. Someone else might have been one of the three main figures in sociology as we teach them in undergraduate courses. And Max Weber didn't have to be Max Weber. So Max Weber seems very aware of the role of chance in the scientific career. And this is, I think, what the difference that we're trying to make between the scientific career and the life course. And they are distinguished, I would argue, by the parameter that we had in the model before, Q. So if Q is high, we get self-reinforcing dynamics. And science is, the reward systems in science where we give opportunities to already famous individuals is very much driven by a high Q, whereas the life course, with all its orthogonal events and chance that lucky things that can happen one day and unlucky things that can happen another day, is much more driven by self-correction. And that is why you will not easily see a Matthew effect take place in the life course. So the conclusion is, in general, lock-in requires a threshold level of reinforcement in these models that I've shown. This threshold is Q equals 1 in the EARN model. You can find beta as 2 if you model it as a McFadden model. And but the point is, there are regimes where feedback is strong enough for lock-in to happen and for Matthew effects to take place. And then there are regimes with weaker reinforcement where everything self-corrects if you allow for enough time to go by. And so, yeah, for the income dynamics, this threshold wasn't crossed. And I would say in the Matthew effect in science funding, the threshold was probably crossed. So we can think of a lot of systems in life more generally where reinforcement, when strong, produces lock-in and Matthew effects, and when weak, produces self-correction. Yeah, in the case of our life courses, this of course means that if you have asked yourself once, if that thing hadn't happened in my life, and if only this thing had gone another way, something very different would have happened to my life. Well, if you're a scientist, I would say, yeah, that may very well be. Probably a stacking of very lucky events early in the scientific career would have produced a very successful career subsequently. Whereas if you're talking about your life course and say, well, if this event hadn't happened in my life course, I would be making a very different wage right now. Then I would say probably you and your alter ego, after some time, would have started to earn about the same wage again. And that's the conclusion of my talk.
Okay, thank you for this fascinating talk. I love this insight, but also like both like formal models and with the clear expectation, then just showing that through the incredible data in both Sweden and US context. I think so everyone has learned a lot from this talk. So thank you for that. So now I can open the floor. Anybody can ask a question by entering your intention to ask a question in the chat box, or just simply you can just turn your speaker on and ask a question.
Sure.
Yep. First, the Professor Ling Zhu. Yeah, you can ask a question. Thank you.
Yeah, it's me. Thank you, Professor Van der Rijt. It's really interesting, and to some extent, I find the conclusions and the findings pretty encouraging for me as a normal person, because it means that the luck or unlucky events is to some extent not that important, even though they are very crucial events in our life course. But to some extent, as long as we want to live better, sometimes we can go back to normal. So this is to some extent a very encouraging finding. To me as a life not normal person. So my question to some extent more like first I think the fund is pretty interesting because at first when I hear I do anticipate it possibly you may find some significant positive effect or negative effect like it has a scoring effect or it has cumulative effect, etc. But it turns out there's no effect. So my first question is that what may be the potential outlet that you would want to send this paper to? I see it's a very interesting finding and it incorporates a lot of studies, but the conclusion to some extent points to no effect. So what will be your potential ideal outlets of this study? So this is my first question. Not directly related to the study per se, but I just want to know. And my second question is more about the Matthew effect or your finding. So you mentioned that, okay, there is difference between your previous finding regarding Matthew effect in getting science fundings, right? And also the no effects here. And you provide some conclusions regarding why there is difference regarding these two findings. And also, I also do some analysis regarding the bureaucratic mobility in the Chinese bureaucracy. And I also find some past dependency on bureaucrats' promotion. And specifically, my finding is different from both this finding, neither this finding or your previous finding. There is no massive effect in the bureaucrats' mobility in the Chinese bureaucracy. Rather, there is negative effect. What does it mean? It means that if you got promotion in your previous job, you wouldn't get promotion for your disposition. So I understand that logic. That logic is more like institutional design. If you have already got the promotion opportunity for your previous position, then you would need to give this opportunity to other people in the bureaucracy. So what I want to combine all these three findings together is, what do you think may be the potential conditions or institutions that people will see different results regarding how your past historical events influence your current outcome. And you provided one solution here, that is the lock-in require a threshold level of reinforcement, which is Q equal to 1. But you just go through this information pretty quick. I just want to know whether there are any formal justification or formalization or test of this conclusion, this threshold. If no, how will you design study to test the validity of this threshold? Yeah, these are my two broad questions. Thank you.
Thank you. So let me start with the first one. First one was, what is your audience for this talk, given that you have what you say a no effect result, and I think the idea is that, well, they're harder to publish than positive effect results. Yes, so that's true, but I would say that the null hypothesis here actually is that there should be a result, right? Because the Matthew effect, cumulative advantage hypothesis is such a established result and is also assumed to exist in the life course. We saw the review article by Depreet and Rijt in 2006, and the conclusion there is not, hey, there is no cumulative advantage in the life course, or things are going to self-correct with time. The conclusion rather is there seems to be a lot of evidence, though not universal, but still a lot of evidence that these effects exist in the life course. So I think the null result here should come as a surprise to the literature on cumulative advantage and disadvantage. So yeah, my audience here, to answer your first question, is mainstream sociology. It's people who believe that the life course is one where from one good things come many other good things, and from a negative event you will see a series of negative events happen, and that things are going to get worse and worse, and inequalities grow over time. following chance events. I would like to convince these individuals that, yeah, this is not supported actually by the facts. It seems that, the source of this this disagreement between the theory and the evidence is that actually most testing of the cumulative advantage hypothesis in life course research has been in terms of comparing one group with another group, the educated versus the not so educated, different racial groups, gender. But then there is already an existing structural difference or demographic difference between the groups. So then you don't know whether any pattern that you might see over time, and sometimes we don't see a divergence or maybe even a convergence, but you don't know whether that is because the group difference is simply changing or whether the event that initially made some people lucky and others unlucky, ceases to have the same kind of effect and the dynamics converge. So I think that that is the message to a main sociology audience, is to reject the Matthew effect in the life course. Then your second question, this was a very interesting finding that you mentioned. And I would think that basically you have a case of, yeah, a negative Q, because you describe a mechanism in which that is specifically aimed to equalize. Is to say, okay, you got lucky, now we're going to make someone else lucky. And so you have a negative correlation between, yeah, luck in the past and luck in the future. And I would think that that is going to follow basically the same dynamics over time as Q being smaller than 1. But the convergence will be even faster because the system is forcing this convergence through the negative correlation between events. So I would imagine that the careers that you're describing, they converge even faster than the careers here in the Swedish and the US register data and survey data. Yeah, that's how I would reconcile that finding. And you asked, I think, a follow-up question in your second question was, what rules or institutional conditions determine which of these 3 cases is going to obtain? Yeah, I can't say anything specific. We're at a very general level here. I would just say whatever makes Q high or low. So I think the reason we expected Q to be higher in the US context is simply because there isn't a social safety net. So that is something that impacts Q, the ability to correct, to not fall through the floor when things go bad, to be secured, and if there's an institutional mechanism that spreads chance, so it equalizes chance, that's an even more forceful mechanism to prevent Matthew effects from taking hold. So this is how I'm seeing it, but I can imagine a whole range of institutional conditions and policies that could impact this degree of feedback in the system. I hope was a very long answer at least.
No, thank you very much for the detailed response. Thank you.
Okay. Lin, if you have a follow-up, then you can also speak. But yeah, this just gives sense. So next question is from Professor Liang.
Yes. It's not a question actually. It's not a question, but it's the finding is very interesting and encouraging, as just Angel said. And what I'm thinking is actually it's a maybe not a alternative explanation, but actually an explanation from your presentation. So uh, but but I'm not sure that it's correct or not. Because your conclusion you mentioned is that you didn't find any mass effect. So in fact, for me, the difference is that for other studies, it probably is only consider a single event. So the lucky event or whatever. So or a single type of event. But in your study, you consider multiple events. So why that will have different results? I think that you actually you mentioned in your formal model. So because there are lucky events, also unlucky events. So and also the events actually are at random. So which means the probability that it's just equal number of events or no, the equal number of lucky events and also unlucky events. And overall, you will find that actually there is no influence. But even in that case, you can consider, if you only consider a single event, single type of event, so just the unlucky, without considering unlucky, probably you can still find the evidence of the massive effect or similar effects. And also in your formal model, so currently you set it as a random process. So just with a probability P or probability Q or whatever. So you can consider it. And this is also related to Angel's finding. So sometimes, actually, sometimes the events are not occurred totally at random, probably caused by some structural factors, which means that you definitely know it's not at random. So some persons are probably just more narky than others. So which means that probably it's not a totally random process at that time. Probably, okay, even in the random model, in the formal model, you will find that it will not converge to you can still find the massive effect in that case. I'm not sure I explained clear enough.
I think I understand what you're getting at. So let me try to clarify a couple of things. So first, the claim that if we look only one event at a time, that's different from looking at many events as I've done in the talk. So it's true that the countervalence comes, of course, from considering another event that runs in the other direction. But in each of these 6 analyses that you're looking at, we are only looking at one event. And then we're just looking at the wage dynamics that follow this event. And in each case, we do find that there is at some point early on a wage effect of the event. So being born in December, we find is bad for your income. Being born second is bad for your income. Having low SCS peers is bad for your income. Not getting into the Stockholm School of Economics is bad for your income. Losing a job is bad for your income, and graduating in a recession is bad for your income. But it's just not bad forever. It's only bad for some period of time, and the effect wanes typically as time goes by. So I would say that these are basically 6 separate individual rejections of the Matthew effect for each one of these events. So if we had done only one study where we had forgotten about all the other events and we didn't even have a model, and I would say, well, not getting into an elite university is going to have a snowballing effect, then I would have seen only the evidence here in the bottom left, and it would show you, no, there is no snowballing effect. It only matters that you went to the Stockholm School of Economics early on in your career. Now, you are very right to point out that in our model, this is, I think, how I understood the second point, there is no room for structural differences. So, right, so losing your job, of course, also is because you might have a more unstable job than someone else. And that might be because you didn't work so hard to get this job or in your educational career, or you're discriminated against, or something that is not a lucky or unlucky thing, but it's something much more to do with classic stratification variables and inequalities as we know them. And you have not incorporated them in your model. If you had, then you wouldn't have seen this convergence happen in the model. So I completely agree with that. And it is worth simulating the model with structural inequalities. But I do know, but it's important for this paper. It's a very good suggestion for this paper. We should do this also to verify this. But I do know that when we run this model with these structural differences, then you get this convergence as well. So if someone systematically has more Red Bulls than some other person, then you also still don't get the lock-in if Q is 1 versus Q being below 1. But I agree that it is very important to demonstrate that. Yeah. Of course, we get around this in the causal analysis through the causal inference strategies, where we isolate the effect of the randomness, and we take out through matching and RDD and all the fixed effects, we try to take out all of those other determinants of experiencing the event, so that we can try to isolate the effects on wage that happen only because of being lucky or unlucky. But nonetheless, you're right that if we look at the lives of individuals who differ not just in a chance event, but also in terms of something else, maybe if we compare them, we do see a divergence or a convergence or an incomplete convergence that goes beyond just the standard demographic differences between those individuals. That's still something we need to demonstrate. And so I think that's a very good point. Thank you.
Yes, thank you very much. So just simply because after your presentation, I think that probably that you're finding just finding demonstrate one thing, that we are equal in terms experience the unlucky or lucky events in our life course.
Yeah, exactly. Yes. Yeah.
Okay, so another question from the floor is a graduate students. Rune, you can ask a question.
Yeah, thank you, Professor. It was really interesting to be really honest. And like following the conversation you were having with Professor Liang, I was wondering if we could add to this model a discount effect, because to the extent I understood it, it was that you have the P event, like let's say the red ball, and the next period, if you have the black ball, then it neutralizes, right? But
Yeah.
what happens if it doesn't neutralize it like completely? What happens if the log effect is cumulative? Like some effects might be cumulative, even though they disappear. They degrade through time, not like from one period to another. So could that might be the reason, like more traditional studies found is like convergent paths to unlucky events ruining your life, basically?
Yeah. So there's two ways to read your question. One is simply, if Q is 1, then what you're describing is what happens. Then if you get lucky early on, so I don't know if you can see the cursor. Can you see the hand on the screen? Okay. So here, right, someone draws a red ball, and this then either is followed by drawing another red ball or by drawing a black ball. So if we follow this line, we have a sequence of red balls being drawn. And what you see is that if you end up here, you are at some point almost guaranteed to stay there. So here, the red balls do not get compensated by black balls, and people do live a very red life with many red balls if in the beginning they got lucky to draw a lot of red balls. So now you said, you mentioned, I had said, well, if we mix in the independent draws, then we can counteract that. And that is indeed what you see for Q is 0.8 and Q is 0.6. So here we also have individuals who draw a bunch of red balls, but it just doesn't stick. Eventually someone is going to draw a black ball, and it's going to happen with a high enough frequency that they will be brought back to the average. And so when you say it doesn't have to be the case of someone who draws a red ball, then draws a black ball to counteract it. It might simply be that they draw a red ball twice or 3 times or 4 times. So then I say, yeah, that's true. But even in all of those cases, we get the self-correction. And that also that was the motivation for showing you just this graph here, because I wanted to show you that even here, if you get unlucky twice, which is like equivalent to drawing 2 black balls or red balls, whichever is the good one, you also get convergence back. So you can have also in an independent world, of course, an unlucky series of draws, even though the first red ball doesn't cause the second red ball, they could still happen. But there isn't the momentum in the reinforcement dynamics because of the diluting draws from the second urn. There isn't a momentum to sustain that disadvantage or advantage over time. Eventually, a ball of the other color gets drawn, and this pushes the dynamic back towards 0. In the regime where Q is below 1, in the regime where Q is 1, then this doesn't happen often enough, and the feedback persists. So I hope that it clarified the dynamics of the model and how it relates to the empirics.
Yes, yes. Thank you very much.
Great.
So another question from the chat box. Let me read it. Thanks for the presentation. I have looked at other well-being related outcomes. Have you looked at other well-being related outcomes other than wage rank from Zurui Tian?
Yes, well, that's a very good question. It's difficult to wage has the advantage of you can look at it over a very long time. So we can do things like look at wages in one's early 20s all the way up to one's 50s. And that's not something you can do for lots of other outcomes. Lots of outcomes are discrete. They happen once or so. Or like education is one you can look at, but it also has a limited time frame. Health is possible. That's continuous, but there are lots of aspects to health, so it's difficult to quantify. But it is definitely something someone could do, and something we haven't done. So to answer the question, no, we haven't. I think the one we are most interested in exploring next is wealth, precisely because one way to problematize the evidence is to say, look, here under firm closure in the US, you're saying, look, this goes to 0, but there's this area under the curve between minus 0.3, this triangular area here. That's the total amount of wealth that's being lost compared to your alter ego. And that means that you weren't able to buy a house that you otherwise might have been able to buy, right? These are significant consequences. So yeah, even if we're earning the same money after 15 years, that means that I have a lot more wealth than you do. So that wealth as an outcome is interesting for that reason. Like probably there's not enough lifetime here. We might not see wealth differences go to 0. That will go more slowly and maybe never across the life course. If we were to look at the same effect of firm closure on wealth, we might see a slowing down of the divergence, but it would probably not go back to 0 in time because they're not, the initial effect is too strong and the cumulative effects of wealth might counteract it enough to see this happen to the same degree. And then, of course, wealth is also interesting because feedback dynamics on wealth are quite different from on income. Income distributions don't, they become maybe a little bit wider over time, but they cannot really explode. They cannot really become extreme, whereas wealth really does become extreme. And there are also very strong feedback mechanisms for the very wealthy. If they have investment options that less wealthy individuals don't have, then we might just be in this very high Q regime where wealth inequality persists and never corrects. So I think wealth is a very important outcome to look at.
Okay, so now I can have the privilege of being host to ask you a question. So I like the Angel's question about the outlet and null finding, but actually I found your finding far from null hypothesis actually is pretty revealing from the null hypothesis that I had, because I somehow thought that the log would have a growth shape of effects before the talk. And that should be only me. Then I came to think of why I thought that the log or chains of log have growth effects. Probably because of the kind of cognition that we have, or kind of visibility mechanism. Because people like me tend to think of log or the chain of unlucky events just very visible. Then why visible then? That I think that people often have an image in mind where the disadvantaged disproportionately experience adverse events. So I think, to complement your research, or some leftover question would be that who gets these unlucky events more than others? So like some of the same kind of unlucky lucky events may have kind of different effects for people. But although like you show that the correlation of all these events are pretty much unrelated, but so that tells us such chain of log happening is very small, but that doesn't exclude that more amplified effect for some strata of people, the small cases that are impacted more significantly by the events. So then I came to think of your presentation, your results, and at the end of the day, you're capturing the average effect, right? So
Yep.
the question becomes like whether you have investigated such heterogeneity effects, because that would kind of like make your findings more fruitful and more informative, and whether adding this kind of like the modeling the events per se would help improve the paper. So that's my question.
Yeah, that's an excellent question. And I agree with that intuition. We can imagine individuals with certain personality characteristics who take a failure and use this as energy to work even harder or do even better on the next opportunity. And then we can see other individuals who are taken aback and discouraged. And maybe what we're capturing here is the average of those two people. And the one self-corrects very fast, the other doesn't self-correct, so on average they self-correct slow. It's very possible. So we have not sufficiently explored this. I would admit to that. The only thing we have done is for the case of the US, which we're looking at here, looked if for African Americans, which, according to theory would have less of a buffer in terms of experiencing a negative event like this for obvious historical reasons, whether we would find a slower or perhaps a complete absence of the self-correcting pattern, and we don't. So we don't see any racial heterogeneity in terms of the trajectory of treatment effects here. But this is, of course, only a sliver of what one could do in terms of heterogeneous treatment effects. An important one, I would say, because race I think, is a very obvious moderator to explore. And we didn't find anything in these data in terms of moderation, but this is, it's only scratching the surface. And I think, indeed, a very important next step is to see if we can find something that differentiates, maybe much more at the psychological level rather than at the demographic level, that could differentiate different sorts of responses to success and failure and setback in life. And I think that's a very interesting direction.
So another kind of interesting thought, slash like some rough thought is that, so you show the old model, right? That I thought about like when our life ends in that x-axis, right? So for example, if our life ends in early, right, then we still see that variation, right? But our life is kind of finite, so we don't really last forever. So
Yeah.
so in terms of the visibility, right? So if our life just ends just probably in the middle of the axis, then we still see a lot of variation, right? But although like your empirical result doesn't support that, so it's but I think yes. So if you like publish a paper, I would say like this kind of discussion, like how much like do we see and why we see that as kind of clearly visible, things like that. So I think that's worth a discussion because like in our like social network literature, we increasingly discuss about this kind of like the cognition and what's really observed and why we see that as kind of significant. For example, like the political polarization paper from Balthasar and Berman, right? So that's also kind of relational dynamics. So it's only like hot button topics, then it comes out like this broken and things like that. I think, although like this topic is really distant topic, but I think what's really under the hood is why we see that as kind of feasible and things like that. Just my second thought.
Yeah. And it's a very good point. That's also why it was important, as you already alluded to really have these register data go back so far in time so that we can really see the convergence happen and not just a sliver of it. And I think, we see in each of these cases, we do see the convergence happen, or at least we reach statistical insignificance within the life course. But again, this is one outcome, and it is these 6 events we've analyzed. And there is a lot, and in many cases, the initial effect is big, and it takes a long time before the thing self-corrects fully. And so again, I think also the point about wealth and other outcomes is interesting in this context of is there enough time to see you know, the fading fully happen, or in reality, because our lives are short, do we never really get back to normal? That is an important question. And in the case of wealth, this is really important because, you know, wealth accumulates over right, it's over the integral of this area here under the curve, and so it would seem to be much harder and would seem to take longer before you overcome that wealth difference. So I think especially for wealth, we might see a faint idea of self-correction over time, but it will probably be stretched well beyond our death. The dynamics where maybe we converge at age 150 or 200. And then, yeah, what is the point? The point is here is indeed also not to say that nobody here suffers from the lucky or unlucky events that they experience, but it is indeed simply to say things don't seem to get worse with time. They seem to get better with time. The differences become smaller with time, but the effects can be big and it can take a long time.
Okay. Thank you for your insight for those on my questions. I think now we are perfectly timed. So I really appreciate your very insightful talk and even better responses to the questions from floor. So both you and also the other audience who asked the questions. So I really appreciate all your efforts. But also we hope that our comments were helpful for you for
They
this
were.
question. Okay.
They
Okay.
were very helpful. Thank you so much for sharing your thoughts with me and for giving me this opportunity to present my work. I really enjoyed the seminar.
Okay, thank you so much. Yeah, so this is it for our seminar. And for audience, just keep being tuned for the further monthly seminar. So we host this line of excellent speakers every month. So so I hope we can see you next month. Thank you so much. Bye bye, everyone.
Thank you.
Thank you, Arnout. Thank you.
Bye bye.
Bye. Thank you.
Bye bye.